Good morning to one and all. Today we will discuss the problems on game theory. So we need to determine whether the given payoff matrix have saddle point or not, and also we need to determine the optimum strategies for player A and player B. Let us see this problem. So payoff matrix is given. So this is the payoff matrix, and player A and player B is given. This is we have player A and player B. Now we need to identify whether the payoff matrix having saddle point or not. See, saddle point means the maximum coincide with minimax, so those corresponding point is known as saddle point. Let us see how to find the saddle point and what is the procedure we need to follow. So we need to follow maximin principle. Maximin principle and minimax principle. Minimax principle. Let us see. I will apply maximum principle. Look at the rows. In the first row, select the minimum element. So minimum element is -3. Look at the second row. Select the minimum element. So minimum element is -2. Look at the third row. Select the minimum. So minimum element is 1. Now we got -3, -2, 1. Here you need to select the maximum. Say maximum is 1. 1 will be the maximum. So this is maximum principle. This is maximum principle I applied here. Or you can say maximum value. This is maximum value. Similarly, find out minimax value. Look at the column. Find the maximum one. Maximum one is 1. Look at the second column. Maximum one is 5. Look at the third column. Maximum is 4. So we got 1, 5, and 4. Select the minimum. So minimum is 1. So this is minimax value. This is minimax value. Now the corresponding, just see here, this 1 and 1 will coincide on particular element. So that will be the saddle point. Say this is my saddle point. 1 will be the saddle point. So now I'll write the conclusion. Saddle point is 1. Game value is 1, which is equals to saddle point. Next, optimum strategy. Optimum strategy for player A. For player A. For player A, optimum strategy is row wise 0, 0, 1. 0, 0, 1. Next, optimum strategy for player B. Player B written as, for player B is column wise 1, 0, 0. This is 1, 0, 0. This is about saddle point. Saddle point is 1, game value is 1. Optimum strategy for player A is 0, 0, 1, and optimum strategy for player B is 1, 0, 0. So this is the first problem. Similarly, we'll see one more problem. Let us see this problem. Determine whether the given problem has saddle point or not. Find the optimum strategy for player A and player B. So this is the given matrix. I'll take the solution for this problem. We copy this problem. Also, I'll take this is 10, 15, 16, and 9. And this is 8, this is 9, 8, and this is 12, this is 4, this is 7, this is 2, this is 1. And this is 12, this is 14, 9, and 6. This is 1, this is 12, this is 5, and this is 0. Now we need to determine whether the given payoff matrix having saddle point or not. And also we need to determine the optimum strategy for player A and player B. This is player A and player B. Apply maximin and minimax principle to determine the saddle point or game value. So look at the first row. So in the first row, select the minimum element. Select the minimum. Minimum is 1. If I go to the second row, this is my second row. Select the minimum element. So minimum element is 7. Go to the next row. The minimum element is 2. Go to the next row. The minimum element is 0. Similarly, column wise, look at the first column. In the first column, select the maximum. Maximum is 15. In the second column, select the maximum. Maximum is 12. In the third column, select maximum, that is 7. In the fourth column, select the maximum, that is 14. In the last column, maximum is 12. Select 12. In row wise, we selected minimum. So here you need to pick maximum. This is the maximum. So this will give the maximum value. This is maximum value. And here in row wise, we selected a maximum in each and every column. We need to pick minimum. So minimum is 7. This is minimax value. We are selecting minimum element from the maximum. This is the maximum elements. Here I am selecting minimum. Now the payoff matrix, now the saddle point is 12. Just look at the coinciding element, this here and here. I will get a coincide with this element. This will be the saddle point. Now I can make a conclude. I will conclude that saddle point is 7. Game value. Game value which is equals to saddle point, that is equal to 7. Next, optimum strategy. Optimum strategy for player A. Player A means horizontally. It says this is 0, 1, 0, 0. So it is 0, 1, 0, 0. Optimum strategy for player B. Optimum strategy for player B. For player B is column wise 0, 0, 1, 0, 0. 0, 0, 1, 0, 0. This is about optimum strategy for player A and player B.